Good day everyone, I am Cadet Kimbo and we are going to report about how radar is set up for operation. Group members: Cadet Kimbo Wiljanjoy, Cadet Ragasi, Michael E, Cadet Manggilimutan Regil. How radar is set up for operation. The general procedure to switch on a radar is: first, visually make sure that the scanner is clear. Second, set the 4 critical adjustment control: gain, brilliance, anti-clutter, and anti-rain clutter or differentiator to off or minimum. Third, set the main function switch off standby transmit to standby. The radar set will then begin to warm up. Certain parts will require time to warming up. Fourth, set range selector switch to desired range scale. Fifth, set PL selector switch to desired position. Short pulses for normal use. In some radar sets, the main function switch is marked off standby short, long pulse, whereby the radar observer has to choose the PL automatically every time we switch on the set. In such a case, omit this step as it is covered by step 9. 6. Ensure that EBL, ERBL, VRM, and range rings are all off by turning down their respective brightness control. 7. Set the presentation mode switch RM unstabilize, RM stabilize or TM to the RM stabilize mode. 8. Adjust panel light to the desired intensity. 9. When the set has warmed up, about 2 to 3 minutes after switching to standby, set the main function switch to transmit. In some sets, instead of transmit, the main function switch is marked short pulse, long pulse, so that PL has to be selected at the same time as switching on from standby. Set step 5. In such a case, set main function switch to short pulse. 10. Generally, increase the brilliance until the rotating trace becomes visible. Then gradually decrease the brilliance until the rotating trace just disappear. The brilliance has now been set correctly and should not normally require adjustment. If and when the 3 other critical adjustment control, gain, anti-clutter, and differentiator, or the anti-rain clutter are all off or at minimum. 11. If a brilliance control is provided separately for the beading marker, turn it down. Unnecessary brightness of the heading marker will 1. Cause the heading marker to be broader than necessary. 2. Distract the observer's attention from targets when the picture is obtained later. 3. This control will not and must not blank out the heading marker completely. However, how the control may be set.
Good day everyone, my name is Cadet Michael E. Ragasi, and without any further ado, let's start. Number 12. Ensure that the electronic center coincides with the geometric center of the display. This can be done by switching on the range rings and verifying that the outermost ring is completely visible and coincides with the circumference of the PPI. If not centered properly, part of that range ring would not be visible. If necessary, center the picture by rotating the center shift as required. Number 13. Check that the heading marker is properly aligned. When gyro is stabilized, it should indicate the correct gyro course. When unstabilized, it should coincide with a 0 of the bearing scale. If not, again, it as per manufacturer's instructions. Usually, a spring-loaded knob is to be pulled out or pulled in rotated as necessary, and then released. Number 14, gradually increase to gain until the receiver noise is just visible as speckled background. The setting of gain would have to be reduced when sewing short-range scales. Number 15, test the efficiency of the set as described later this chapter. Number 16, adjust other controls as necessary. So the next is about radar resolution. There are two important factors in radar resolution: bearing resolution and range resolution. Bearing resolution is the ability of the radar to display as separate pips the echoes received from two targets which are at the same range and close together. It is proportional to the antenna length and reciprocally proportional to the wavelength. The length of the antenna radiator should be chosen for a bearing resolution better than 2.5 in the IMO resolution. This condition is normally satisfied with a radiator of 1.2 or 4 feet or longer in the X-band. The S-band radar requires a radiator of about 12 feet or 3.6 meters or longer. So next reporter.
Good day everyone, this is Cadet Maglimutan, and for the bearing accuracy, one of the most important features of the radar is how accurately the bearing of the target can be measured. The accuracy of bearing measurement basically depends on the narrowness of the radar beam, and however, the bearing is usually taken relative to the ship's heading, and thus proper adjustment of the heading line at installation is an important factor in ensuring bearing accuracy. To minimize errors when measuring the bearing of a target, just put the target echo at extreme position on the screen by selecting a suitable range. And for the range measurement is also one of the important functions of radar. Generally, there are two means of measuring range. This is the fixed range rings and the variable range marker, or VRM. The fixed range rings appear on the screen with a predetermined interval and provide a rough estimate of the range to a target. The variable range marker or marker's diameter is increased or decreased so that the marker touches the inner edge of the target, allowing the operator to obtain more accurate range measurements. And this is the illustration which shows the range measurements and the bearing accuracy.